Hello, everybody. I'm Peter Lurz. I'm an honorary fellow at Edinburgh University, but for this work, I'm giving you an overview of modelling studies, which I've done with Andy White and Andrew Slade at Heriot-Watt University. And I realize I'm kind of preaching to the choir here with a slide like this, but for one reason, I wanted to show Andy and his support for red squirrel conservation. And you all kind of know how popular red squirrels are and that they're declining, and protecting them should really be a priority. And sort of mathematical models, the big picture. Normally I give talks where I chase squirrels in the field and look for the research regions that confirm why red squirrels are being replaced by gray squirrels. But mathematical models are kind of a step after that, and they're tools. So based on this field research, you can come up with a set of rules, and it's a bit like what Ewan presented now. So we can incorporate information from research and put them into the models and say, okay, if this is the case, what would happen if? And then you can predict into the future. And using that, you kind of can inform management of gray squirrels, and usually there's limited money, so the models can kind of help you target these limited resources. And so I didn't want to start with lots of math equations, and so to explain what the model is really, I thought this might help a little bit maybe. But essentially, if you imagine, we have habitat information. So in the normal case of events, this would be a satellite map, a land cover map of the forest cover in Scotland, or a Forestry Commission's stock map. And then linked to that, we obviously know from field work how many squirrels you have in a pine wood and how many squirrels there might be in a spruce wood or in a broadleaf forest. And we know how this changes based from the sort of squirrel research in terms of when you have a mass seed crop, so when all the trees sort of produce tree seeds, and then usually you have years where there's very little produced for some species. And we know then from the squirrel research what that means in terms of density and how many young the squirrels have, and if mortality goes down or up. And if you combine these sort of information for the gray squirrels and red squirrels, and also what we know about competition, you can then make predictions. And this is a sort of example. On the left here, you see the land cover map of Scotland, and obviously the green is the forest cover. And then additionally, we know from studies how often a beechwood has a mast interval, and we know it for Scots pine and Norway spruce and Sitka spruce. And so we know at what age these trees normally start to produce a first crop. So you can look at succession, and you can put all that together, and you can also add information on squirrelpox virus. Now, I don't have to tell you about the virus. Most of you will know about it, but we can build this into the model to see what happens. And essentially, you know, if you put all that together, so you have the competition between the two species, and obviously that affects potentially how many young they have, the births and their reproduction. And then you also have effects of gray squirrels on reds, but you do also have effects of reds on grays, but usually the effect of grays on reds is much, much bigger than the other way around. And clearly a disease, squirrelpox virus, but increases mortality of red squirrels. And in 2006, which seems a long time ago now, I was part of a paper. We looked at this for different regions, and we found that squirrelpox virus, when it's present, can increase the speed of red squirrel replacement by 17 to 25 times. So disease, when it is present, can have a big impact on the decline of red squirrels locally. Although I have to say that there are many areas in Scotland where this is not the case. Everybody of you, we've had this for 2 years now with COVID, but one of the messages clearly is, you know, for an epidemic, you need actually enough bodies that can be infected, and the lower your density, the less likely it is that an epidemic takes place. So densities and habitat quality obviously play into this. And this is the math now. This is why you have math profs and PhD students on math, and I'm the kind of field ecologist in this to add the squirrel side. And but this is what it looks like. It's basically a set of rules, and then you put all that together, and then you apply it. And just to show you what this does is, this is sort of older work where on the top here, you see red and grey squirrels. This is going back to the 80s in East Anglia, where Jonathan Reynolds studied the decline of red squirrels and the expansion of greys. And this is kind of the pattern that he observed in the field. And when people tried to replicate this to understand, competition alone just didn't work. And Andy White, who I work with, when they developed a model that included competition as well as disease, a squirrelpox virus, you can see that they could almost perfectly replicate the pattern that was observed in the 80s in East Anglia. And that's kind of what you do. You develop a model, you put in what we know, you make predictions, but then you usually try and find also a data set where you can actually calibrate or validate your set, so that we know, is the model actually in the right ballpark. There's always variation and stochastic events, chance, but you want to know whether the model can actually predict what happened. And so this is what happened here to test the model. And then what can you do? How can you apply it? When I said it was a tool, so you can obviously look at grey squirrel expansion like in Scotland, or you can look at how squirrelpox virus might spread with grey squirrels. And you can see what control efforts do. You know, do we need more? Do we need less? Where do we need it in the landscape to have the biggest impact? And in terms of felling and replanting, you can sort of use the model to say, okay, if we go with this forest design option, so if we fell now and replant with this on a forest scale, what will happen to red squirrels? And those are the kind of things that you can do with a model. And I only have 15 minutes, and we've applied this quite a lot. So I'll just give you a few examples. And there's a website at the end at Andy's University where if any of you are interested, you can download any of these papers or reports that we've done. But we've looked at grey squirrel control efforts on Anglesey. We worked with Craig Shuttleworth on this and looked at and recapitulated basically what happened when greys invaded, reds disappeared, when they then controlled greys, and then reds came back. And we've also looked at a long-term forest management policy or policy options for red squirrels in Scotland. This is with Forest and Land Scotland. And this was published last year where we sort of compared different policy options and where you should apply them. And we looked for natural strongholds, or what we termed natural strongholds. I don't have time to sort of go into details, but if you might know that grey squirrels are kind of a broadleaf species, and reds occur in both broadleaf and conifer. But when you add greys, it's the broadleaf forest that reds disappear the quickest from. And so we looked at, does Scotland have forests that are kind of natural strongholds where you wouldn't do a lot of, or need to do a lot of forest stronghold management and still keep reds? And you can find the sort of findings of that there. And when we all started this, we also did a modelling assessment of control strategies to see if you could stop squirrelpox spreading into Scotland, and work with MEL and SWT on this. And so this is one of the example maps. So this is not a devolved Scotland, it's just that we didn't have land cover data for England on this side. But if you, in 2006, when there was the first pox case, introduced pox in that area where it was found, you can make predictions based on the land cover data, your control effort, and grey squirrel distribution, how squirrelpox might actually spread. And you can see that there's a sort of expansion, and the darker the color, the higher the chance that the area has squirrelpox after a while. And by about 2014, it takes a while for the south of Scotland basically to fill. And in this area here, you have a kind of gap. There are very few corridors that actually link the south of Scotland to the north. There are some, and it takes a while for these to be used and the pox basically to jump north. But remember that it isn't just grey squirrels spreading, that there were already grey squirrels in that area. So the pox, once it's in there, as you can see, it spreads very quickly because it's spreading through extant populations. This isn't a few single greys moving north. There's already greys here from the introductions from 1919 to Edinburgh and to Fife. And what we've done of late, sort of recently, is we also added pine martens to disease and composition to see what would happen if pine martens sort of are added to the equation, what happens to our reds. And Emma, after me, is going to tell you lots about squirrels and pine martens. So I'll keep this very brief, but you know, they're a protected species and the numbers, thankfully, are increasing in Scotland. And if you go to the National Biodiversity Network, this is the kind of information that you get. This is the distribution where you'd find pine martens in Scotland. And so you can put that into the model. And as you know, pine martens feed on many different species. There's voles, birds, mice, and squirrels, including greys. And on the bottom left, I was out a few years ago with Johnny Burks when we checked nest boxes for martens, and we had one with 2 young in there. And I think we counted 46 mice and fledgling birds and a few frogs, no squirrels, in that one. The female pine marten had provisioned the young with more food that they could eat. And this was the sort of booty that was below and in the nest box. And so from Emma's work and Colleen Lawton's in Ireland, where pine martens are seen at high numbers or increasing numbers, grey squirrel numbers start to decrease and reds can come back. And so here's a snapshot that we did with the model for this talk as a sort of a hypothetical. And on the left-hand side, you see without grey squirrel control, and all the red areas is where red squirrels are. Where there's orange, you have red and greys, and then obviously where you see that bluish grey color, this is the snapshot grey squirrel distribution when you start it from the known distribution and let it spread. And if you add pine martens to this, from what we know from the published papers so far, then you can see on the right that obviously the areas where red squirrels are present is much larger, and grey squirrel distribution is decreased. So this is a hypothetical sort of based on research that is ongoing, but that's the kind of thing you can use the model for as a crystal ball and see what would happen if this happens. And so the habitat of Scotland, when you look at it on the paper, is large conifer forests, which favours reds over greys in terms of competition. And the return of the pine marten will likely reduce grey squirrel numbers in some areas. But to me, Emma might say more about this. It's not a universal fix. I mean, you don't get pine martens in urban areas, and so that there will still be areas where you have lots of grey squirrels that are expanding outwards, and other control efforts might be needed in these areas. And there are large areas of the country where you don't have pine martens. Oops. And yeah, so. Thank you for listening, and if you have any questions, we'll be back later on for a Q&A. And below here, you have the website where you can access any of our work and download it. So it's obviously at www.max.hw.ac.uk at Andy White at Squirrels. So if you're interested, please download it. Thank you.